So good morning, students. And today we'll be looking at a very nice framework called Huggingface, in which probably a lot of you has heard of. And basically, Huggingface is a go-to tool for using any pre-trained models, right? Especially like large language models or large computer vision and also multimodal, right? So today, our tutorial will be split into several parts, and in today is a basic tutorial in which we go over the concept of pipeline, and then we're gonna look into the component of each of the pipeline, including tokenization. The second component is the model itself, and then the third component of the pipeline is the processing, right? So the idea of pipeline is basically you just use it right away, like just two liners, and then you can get what you want, right? But if you want to customize like the tokenization methods or the model or the processing, then you can also customize them accordingly. All right, great. So without further ado, why not we begin right now? So let us import something. So to use Huggingface, we need to import something called transformers. And let me just show you the version I'm using. Right. And we're going to also use something called evaluate. So this is for measuring the performance, and it's bundled together with Huggingface. All right. And I'm gonna also use data sets. This also come together with Huggingface, right? And lastly, I will be importing accelerate. So accelerate is well, in PyTorch you can train your model by yourself, right? In Huggingface, sorry, you can also train your model by yourself. But if you use the accelerate method, then provided by Huggingface, you can make your training much faster. Probably there's some kind of methods that can help you parallelize your training, right? For example, right? Of course, if you want to train by yourself using something like DP parallel, right? Definitely that is also possible. All right. So those are things that you would want to import and make sure you pip install everything. And now let us start with some pipeline, right? So the pipeline is a very nice concept, right? That is, you can use whatever pre-trained model in the Huggingface, right? For example, I want to do sentiment analysis, right? I can just do from transformers, import pipeline. Then what I can do is the classifier is simply a pipeline. And what it does of this pipeline is sentiment analysis. And the model I want to do is this one I have to copy from the internet, right? So I have to be careful that the name is correct. And usually whether you get this name, well, you just get it from the Huggingface page. Uncase is probably meaning that it's not sensitive to cases. Fine-tuned is fine-tuned on some sentiment analysis data set. And SST is basically a data set for sentiment analysis. 2 just meaning it's SST2, right? And it's for English, right? So once we do that, we can use this pipeline. For example, I love Huggingface so much, right? And you can see that it can quickly label that it's positive and the score is 99%, right? So yep, this is the idea of pipeline, right? and there's not much you can customize. You just use to write everything right out of the box if that is something you want to do, right? What else are the other things you can do, right? Well, there's so many things you can do, right? Uh, by the way, you can do I do not uh, uh, I do not love so much, right? And that probably is able to do negative, right? So yep, that is a good sentiment analysis example that it negates this one, right? But anyway, let us move to the next one. So we can also do something called zero shot classification. So what is zero shot classification? Well, zero shot classification is the idea that hey, you don't need to train you don't need to train this model, and this model never see this kind, and you want to classify it right away, right? So the question is, can it do? And the answer is a lot of the time it can do quite reliably well using its internal knowledge, right? So for example, I'm going to use something called Facebook. It's by Facebook, Bard Lodge, NLI, right? I guess NLI stands for natural language inference, and M is probably stand for multilingual. Yeah, and BOT is a very famous encoder decoder architecture like thing. But if you don't understand that, don't worry. As you study my course, I mean, you should probably better know that. So I can try. This is an NLP course on Huggingface. Right? And what I need to send it is a candidate labels, right? Because it never see, it does not know what we want to classify, right? So we're gonna say education, tech, sports, right? And I guess the closest classification is you can see that tech has the highest classification, and education is the next, and the sports is the least, right? And this all sum up to one according to softmax. Basically, this is softmax, right? So yep. So this is also demonstrate. So again, for those who don't know where they get this, you just get it from Hugging Face, right? All right, so now, and if you go look at this one, you would say that which pipeline does it support, right? The next thing, well, I can do, for example, the generation, right? So I can do pipeline text generation, model equal to distilled GPT-2. So GPT-2 is a next token generation architecture by OpenAI, and now they have GPT-3, right? But what does this do? This is basically a smaller version of GPT-2. Basically, it this GPT-2 actually learned the label from GPT-2, which is a bigger model, right? So this is called a process called distillation. But anyway, we're just gonna use it right away. So we're gonna say AI is transforming our lives, our everyday lives. Yep, and hopefully it can continue the sentence for us, right? And then we can specify a lot of things. For example, max length equal to how long we want it to be, like 100, and how many sequence we want back. So we can say num return sequence, and let's say we want to, right? And yep, I think I have probably some errors. Let me just check. Max length, yep, I should not put a string here, right? So you can see AI is transforming our everyday lives into the most vibrant. A lot of so it does not work always well, right? And then and even the most modest, affluent, and socially connected. Okay, people we know may feel a little bit okay. That is a little bit weird, but anyway, that is text generation. There's so many models you can use nowadays. Now that is 2023, and I haven't been updated to all the models available. Like it literally every month has like 10 models coming up. So it's crazy, but you can definitely try it, right? Another of my favorite is probably mass. So you can do mass language model, pipeline, mass, and model equal to distilled Roberta. Yep. So Roberta is basically is based on bird. It's basically trained on masking, right? And Roberta is basically adding more layers to bird, and this still is basically this still version, like just like this still GPT, right? Sorry. And then what we can do is we can do Chucky loves to teach deep, and then we can put math here. And then we're gonna let it return maybe the top three possibilities, right? And then maybe I have some mistake here. Okay, I should have MSK. Great. So there's some warnings, and this warning you can't ignore it. Basically, it's just saying that you may want to further fine tune it, right? But if you don't expect to fine tune, you just want to use it, it's okay, right? Something along the line. So you can see that the learning has a very high probability of 15. The next thing is breathing, deep breathing. Yeah, probably, and also the deep truths. Yep. So that is the idea. Oh, you can see that this all does not really sum to one, right? Because it's top K, right? If you take all the top K, like all the K, then probably it's sum to one, right? So great. So mass is also a very great pipeline you want to try. Question answering, right? By the way, when you type this, it should be exactly like this. And then the model that you use should also support this pipeline. Yep. And so this still bird again, base. For those who are wondering what is basics basically, like there's so many, like this is the base model. There are large model, small version, etc. And this is case. This still on squad. All right. Right. So squad is a very famous data set for question answering. All right. So now what are we going to do is QA. I'm going to say question. Where do Chucky work? Yep. And then I need to put some context, right? That is the problem, the problem framing by Squad, right? So you need to provide question and some context, and then it can answer based some context, right? So my name is Chucky, and I love to teach at AIT. Yep. So hopefully it can grab this AIT. So, boom. And you can see that the start token is probably 40 and the end token is 43, right? And the answer is AIT, right? So it does very well, even though this is like, it is not, it never see this, right? So this is like some kind of zero shot question answering, right? The last thing I want to show is a gender bias, right? That is something you may, every young generation may want to know. That is and you may want to be aware, right? So we can copy this. Okay, I'm just gonna type again. So you're gonna say MLM, mass language model, pipeline, mass, right? And here I'm just gonna use a model called distilled Roberta base, and then this man work as and what I'm trying to say is that you can see that using this model, there's some tendency that it try to make the man works, right? But that is something called gender bias, right? Which is not something we want. So we're gonna just print the result. Right. So you can see that translator, consultant, bartender, waiter, courier. And if you change this to woman, then probably there's some kind of gender bias clearly seen here. Right. Waitress, nurse. So this is not something we want, right? So a lot of research also has been done on gender bias. So great. So hopefully now you understand that idea of pipeline. So whenever you look at Huggingface, there's two things you need to do. You can search according to the pipeline and then the model that it support, right? So that is something you want to take a look, right? So that's done for the pipeline. Now we can actually take a look at deeper, like what are the components inside the pipeline. In case a lot of the times when you actually do research, you don't actually use the pipeline, right? You want to customize the token you want to use, the model you want to use, the post-processing you want to use, right? So that is on the research level, right? So the tokenization, so from transformers, import auto tokenizer. Auto tokenizer is basically like I'm not sure you guys are familiar with software engineering, so this is like a high abstract class that you can put any tokenizer and then you can convert into concrete tokenizer. But if you don't understand this means whenever you want to use tokenizer, you just use auto tokenizer. Is very convenient. So we're going to do checkpoint equal to so this is a very long, so I'm just gonna make sure I copy from Huggingface. Give me 1 second. Okay. Checkpoint basically is saying that, okay, we want this model, right? And checkpoint is just a term to say that it's fine-tuned based on this, and we're going to call this a checkpoint. It's called model checkpoint. And tokenizer equal to auto tokenizer from pre-train checkpoint, right? So what this is basically saying that, hey, we want to use the same tokenizer that is used in this pre-trained model, right? And then you may wonder what is tokenizer, right? So for example, raw inputs equal to, let's say, Chucky has been waiting in queue for sushi, right? And maybe second sentence, Huggingface can do lots of stuff. So make sure you try everything. Yep. All right. So that is my raw inputs, and now I can do inputs equal to tokenizer raw inputs. Yep. And padding equal to true. Truncation equal to true. And return tensor is PyTorch. Yep. So if you're using like TensorFlow, you can always change to TF. I think TF stands for TensorFlow, but here we are using PyTorch, so we wanted to return as a PyTorch tensor. So yep. So here you can see that a lot of things happening here. So this is the tensor, right? So you may not know what is this. So what we can do is we can do tokenizer.decode, and what we're gonna do is we're gonna just decode like the first one. This belongs to probably the first sentence, right? So the tokenizer, what it does is basically add the CLS thing and then lowercase everything, right? And of course, separator is something that split the sentence, and then there's a lot of padding. This padding is added up according to the longest sentence here. Right. And of course, we can try the second one. Right, so you can see there's no padding because it's a longer sentence. Now you may see another parameter is called attention mass. So notice that in attention mass, the first one has a lot of zero here. This is just trying to say that you should ignore this 4 thing because this is a padding, right? But for the second sentence, the attention mass is all 1, so that you don't have to ignore anything, right? So that is so this is what Huggingface tokenizer gave you, which is very super convenient. Great. So now we can actually take a look at the second component of the Huggingface, which is the model. And now we can do from transformers, import auto model. So again, auto model is an abstract class of model, allows you to import any model, and then it can just turn it into concrete class. So again, I'm going to do checkpoint equal to copy right from the Huggingface, and I'm going to say model equal to auto model from pre-train checkpoint. Great. Now we got the model, right? So we can do a lot of things, right? So here is our inputs, right? That we have already done. We have tokenized. So what we can do is because tokenizing is the first step of the pipeline, right? So now we can actually send these inputs to the model, which is the second part of the pipeline, right? So what we can do is outputs equal to model. We call it model, right? And because this is a dictionary, we're going to need to put 2* to make sure that it knows this is a keyword arguments. And then we can do it now. Now we can print it outputs a little bit, right? And it's a little look. So basically, this is the last hidden state, right? And return a tensor, right? So that you can do dot last hidden state, and this is the last hidden state, and we can dot shape, right? And we got some numbers 2, 17, 768, right? So I guess if I'm not wrong, this is batch size, right? And this is a sequence length, the longest sequence length of the sentence, and 768 is probably the hidden state of this model, right? So yep, and so this is what it does, right? Now, breaking into the last component, right? After we send it to the model, maybe we want to understand what is this actually, right? So we can now post-process it. So what we can do is we can do from transformers import. I hope you guys understand why I'm doing this, right? Because a lot of the time you don't want to use the pipeline. You want to customize a lot of things inside. So definitely you want to break them. This too, okay. Let me just copy. Yep. And model equal to yep. Yep. So this auto model for sequence classification is basically any model that has add 1 layer, right? Which is for sequence classification, right? So you can do this, right? And then now we can say outputs equal to model inputs. And then we can do outputs dot logits, right? So now we can see a lot of numbers right here. And obviously you can see that this is the something for the first sentence, and this is for the second sentence. So to understand this, maybe we want to print the config dot, I don't remember, maybe ID to level. Yeah. Yep. So we can see that this is probably meaning is negative and this is a positive, right? To understand this much better, maybe we'll want to softmax these logits, right? So we can do import torch predictions equal to torch.nn.functional softmax and outputs dot logits, and dim is equal to, give me 1 second. Okay, so this 2 sentence and this okay, probably dim equal to 1. Yep. Okay, so let's keep it that, and then boom, right? Yep. So it seems like the first sentence is more of a negative sentence, and the second sentence is more of a positive sentence, right? Of course, you can do torch.max, and then now you can probably get 0 here for the first sentence and 1 for the second sentence. I don't remember what is our sentence. So this is a negative sentence. Whoa, waiting in queue. So it's very smart to know that this is actually negative, right? And this is a positive. So that looks great. Yeah. So this is a negative sentence, waiting in queue, and learning Huggingface is a positive sentence. Great. So yep, that's it for Huggingface. So that is the basics. So in the next tutorial, we will probably look at some more case study. Thank you very much. Bye-bye.